In this video, let's build on your knowledge of neural network components and learn how transfer and activation functions work. A traditional artificial neuron is composed of some weighted inputs. A transfer or transformation, which is any function that takes the weighted sum of the inputs to a neuron and produces an output value. And an activation function, which is a special type of transfer function that introduces nonlinearity into the neural network. Although the images show two distinct steps, the transfer and activation functions occur inside one computational node. Let's add two features from our housing dataset to understand the mathematical calculations that occur inside a computational node. This image shows two features: house zip code and ocean proximity. Which do you think has more influence on the predicted price? This network takes numerical inputs x1 and x2 and has weights w1 and w2 associated with those inputs. The numerical and weight inputs are summed together, thus the summation symbol in step 1. Additionally, there is another input 1 with weight b called the bias. The bias can be defined as the constant value which is added to the product or multiplication of features and weights. It is used to offset the result. It helps the model to shift the activation function towards the positive or negative side. Step 2 is the activation function. After the numerical and weight inputs are summed together, the node then applies a function f to the weighted sum of its inputs. The function f is nonlinear, and its purpose is to introduce nonlinearity into the output of the node. Since most real-world data is nonlinear, you want to make sure that the nodes learn these nonlinear representations. Note that the node learns both linear or nonlinear decision boundaries based on the activation function. There are different types of activation functions. These three are the most widely used. The ReLU function is a nonlinear function that has a linear shape for positive inputs and a zero output for negative inputs. It is a popular choice for neural networks because it is computationally efficient and easy to train. The sigmoid function is a nonlinear function that has a sigmoid shape. It's often used in neural networks because it can produce outputs that are between 0 and 1. The tan function is similar to the sigmoid function, but it has a range of -1 to 1. And this makes it a good choice for neural networks that need to output values in this range. Take a moment and think about the activation function shown in this image. What type is it?